Okay, so we're back, and today we're gonna go over something really important when it comes to programming, and that's our data structures. So hopefully by the end of this video, you'll have a grasp, or rather a solid understanding of what a data structure is and how to use it. Okay, so what is a data structure? Well, a data structure is a way to organize and store data in such a way that it can be accessed and modified efficiently. Well, that's the textbook definition. So what I want you guys to think of is like, imagine a data structure being like, an array of containers, like a lot of containers, right? So they can store stuff. But then you also have to have a way to like, quickly and easily get that stuff, exactly what you want at the moment you want, you know what I mean? So that's the aim of a data structure. It kind of, wants, like, it allows you to store data and allows you to quickly access specific data that you're looking for. So in Python, the most common ones I'd say, the lists, the sets, the dictionaries, and the tuples or tuples or whatever. So those are the ones we're gonna cover today. Okay, so the first data structure I want us to go over is the list. Okay, a list. Well, the way you create a new list is like so. You can either type in list and then call it or whatever. It's gonna return a new empty list, or just assign it to like some square brackets, and it should give you a new list. Let's just print this out to see what it's gonna give us. As you can see, it's an empty list. But then if we want to, you can start adding stuff to it. You can start adding some data to it, and then if you print it out, as you can see, it's just like a collection of data. Okay, but then when it comes to lists, unlike in other programming languages, it doesn't have to be like a specific data type. So like if I want to, I can like add a new, what's this, a string and like a character or whatever, and it should still work. As you can see, it works. Now lists have this property, should I call it a property, but whatever. They have these things called indices, right? Like I said, with data structures, you want to be able to like efficiently get the data you want, type shit. All right, so these indices are kind of like the positions in the list basically. So this is like the first position, second, third, fourth, and so on. But then when it comes to indices in most programming languages, including Python, they start from zero. So this one is at index 0, index 1, 2, 3, 4, and then 5. So for example, we want to access this string pixel, right? It's at what index 5. So if I want to, I can just put a square bracket there and then the index, then say I print it. It's just gonna give me that 5, whatever. It gives me that element, right? So let me do something here. Say I decide to like print this, right? And then do this. We say that the thing at index 5 is this thing, right? This string pixel. So say we change it to the number 6. We have modified the list. So now print it, it's gonna be like notes. We're gonna print it before changing and then print it after changing. So you should see a difference then. So yeah, before we changed this string pixel to a 6, we had this, and then afterwards we had this. So that means you can change stuff using, more like you can change the elements inside a list. It's not immutable. But then lists, besides having this property or whatever they're gonna call it, we also have these methods. For example, append. Whatever goes into this append method or function or whatever, it's going to be added to the list. But like, wait, let me just show you, you'll understand. All right, so before we did the append, we had this, right? Now we appended this 0 to the end, so we just added it to the end of the list. And besides append, let's have a bunch of methods you can use, like this remove thing. We have insert, I think we have like extend. There's a lot you can play around with. Okay, so let's move on to the second data structure, which is the tuple or the tuple, however you want to pronounce it. So how you create a new one is you type in tuple and then call it, or assign it to a pair of parentheses. Then say we print it, yeah, it's empty. So wait, let me just add some stuff to it. Alright, so yeah, I'm sure you're noticing some similarities between a tuple and a list. But then firstly, wait, let me, before I forget to mention, it does support this indexing thing. But the main difference between a Jesus, where did I get that? Okay, the main difference between a tuple and a list is tuples are immutable, meaning that you can't change the elements inside of it once they have been, once the tuple's been created or whatever. Alright, so say for example, we take the thing at the third index, which is the number 7, right? And then we change it to the number 10. It's let's see, it's going to give us an error because, like I said, tuples are immutable. So as you can see, tuple object does not support item assignments, meaning you can't change it. So this begs the question, when should you use a tuple and when should you use a list? Okay, so with lists, I'd say use them when you expect to, like, add, remove or modify the elements inside your collection. Okay, so like, yeah, basically that's it. But then if you expect what's this if you want to keep this collection constant, like in the case of, say for example, coordinates or, like, settings, if you don't want them to change, then that's when I'd say you've got to use a tuple. Okay, but then it's not a must, you can choose to use it, it's up to you. Okay, so now we move on to, like, the third and honestly my most favorite data structure, the dictionaries. Okay, so how you create a dictionary, let me call it and then this is how we, what this, you'd create a new dictionary, or just assign it to a pair of curly brackets or whatever they call it. Then say we print it, this is what you should get. Okay, it's an empty dictionary. So what exactly is a dictionary? Let me try to explain. So it's a collection of key value pairs. So like, imagine like in an actual dictionary, right? You have a word, and if you look for that word, it is mapped to, like, its definition. Okay, it's kind of confusing, but something like that. Okay, but then how I want to explain it, okay, or rather how I kind of understand it, let me give a simple analogy. Okay, let's say you have a list, okay, filled with people's ages. Let's say for example, John, he's 10. We have a person named Amy, she's 20. Maybe there's you, your class, I don't know, 16 maybe. Maybe there's another guy, Jimmy, he's 18. And then we have George is 27. You see, like, it's gonna be a problem having to memorize the indexes for all the different people. Okay, sure, you can, I don't know, put a comment and be like, one is equal to, like, John, for example, or and then be like two. Well, really, there should be a zero because the indexes and stuff. Then we'd be like two, or sort of one is equal to what Amy and stuff. And then every time you wanna use the age or the value for the age or whatever they call it, you have to remember the index. You, like, I don't know, maybe this is like John, right? You print it, okay, sure, that's John's age. Wait, which one's my age again? Is it this one? It becomes complicated. Okay, it becomes a problem. Wait, chill, what did I just do? Okay, yeah, it becomes a problem. Okay, ideally you'd want to do something like so. Let's say for example, under the ages we have what? John. Okay, now we just print out his age. So this is where, like, dictionaries are useful. Let me clear this. You can do this actually, so it kind of creates these custom indexes, not really indexes, but like, they're called keys. Okay, so let's create a dictionary so that I can kind of demonstrate. Okay. So John, we said what is 10, right? We said Amy is like 20. We have me who's like 16, and then maybe we have I don't know, like George. My God, I swear. Let's say it's like I don't know, 27. Okay. Now say we wanna print ages. Maybe Amy, for example, right? See, we get our Amy's age. Okay. Say we want let's see, my age. We can print it. See, these are really useful. Now another advantage is these ones I say to be like faster when it comes to lookups. So like let's say when you're actually looking for a value, like this, it would be faster than a list on average, apparently. Not sure why, but I'll look into that. But then, so when do you want to use this? So these are like useful when you have like IDs mapped to certain values and stuff. Like you see, the name can be the ID, the value can be the age. Note, it doesn't always have to be a string. Then, if I want to, I can just put like a one, for example, as the key. Okay. uh Again, like, and it still works. Okay. So with dictionaries you can map anything to just about anything. So it's kind of, it's useful to have something like this. Okay. So say mapping the string to like an integer in this case. Okay. So let me remove this one, John. Yeah, just in case you forget what you have to, like, what kind of list it is. Okay, but yeah, sorry, dictionary, not list. But yeah, that's just about it with the dictionaries. They're really useful. Okay, so the last data structure we're gonna cover in this video is the sets. Okay, so how you create a new set. Let me say set A. Let me call this A. You do the following. Okay. Now, why I'm not gonna do this is because this is how you'd create a dictionary. I'm not sure if there's a way to like specify that as a set, but like, so you have to stick to this when you're creating an empty set. So say we print it, what do we call it, set A. Yeah, it doesn't look like the other thing is, but then now say I do something like this, 1 3 5, sorry, 5 7. Okay. Yeah, so don't confuse these with dictionaries. These ones are kind of more similar to the lists, less like a dictionary. Okay, so now what makes these things unique? Okay, so like that's sort of a pun, you'll understand in just a bit, is it only accepts unique values. So for example, if I decide to put another 3 there, uh maybe a 4, another 4, another 4, maybe a 7 there, say we print it now, you see over here we have 5 numbers, but then here we have that many numbers. But then, like, you notice that some of these numbers are repeating, like there's 2 3s, there's four, what's this, 3 4s, there's 2 7s. It's only gonna take one of them, so like it only accepts unique values. Okay, that's the first thing to note about a set. Okay, number two, if you're familiar with the sets in mathematics, as in those are, what are they called, sample spaces, when it comes to calculating probabilities. These ones are kind of similar, as in they have these methods that make them similar to those sets. So let's say, for example, I create a second set. Maybe this one only has like 1 3 and oh sorry, 1 5 and 3. Okay, so we have these methods that allow us to, well, they're used mostly when it comes to data science, like for example this intersection method, I think, wait, what does intersection mean again? Okay, this intersection method, it will return a new set with elements common to the set and all others, okay? So it will only return the numbers that are found in both sets, okay? Like for example, 1, 3, and 5, okay? See, 1, 3, and 5. Maybe we get like something like difference. Now, it only gives us the ones that are inside set B, which are 4 and 7, okay? And then we have union, again, which is just gonna add up all the sets, but then again, like, remember, it's, I don't know how to put this, but then yeah, it's gonna take all the values that are found in all of these, but then again, they have to be unique because it's just gonna create a new set. So yeah, that's just about it. Me personally, I don't use these, but then maybe, yeah, other people use them. I don't know. Maybe you guys are gonna find some use for them. I don't know, but then yeah. Okay, so that was it for the introduction to data structures. Today in this video we went over lists, we went over tuples, dictionaries, as well as sets, and I feel like for now knowing those is really important. There's some stuff that I didn't include in this video because it's already getting way too long, but then we'll go over them in the coming videos as we use these data structures and get used to them. So yeah, again, if you like this kind of content and wanna show some support, consider subscribing. It doesn't cost you anything, and it helps out like a lot. Thanks for watching, by the way.